Okay, the first three problems all basically were the same type of radical equation problems. They all had the square root equals a number. We squared both sides. We got a number squared. It was pretty straightforward. Example 4 is starting to get a little bit more challenging because instead of just having a number here, I've also got a plus x. I want both of these things to move to the other side. So on the left-hand side, I've got the square root of x minus 1. Again, priority 1, get the radical expression isolated. Then I want to move both those things to the other side. The negative 3 moves over, becomes a positive 3. The positive x moves over, becomes a negative x. Right. So again, first step is what it was before. The square root expression all by itself equals everything else. Now this is the step that is a little bit different, and it doesn't really seem that much different right now probably to an Algebra 1 student. If I had Algebra 2 students, they'd notice it more. But I'm going to square both sides. What I want to focus on is the structure of this side. So this side is going to be what it was. So this will just be x minus 1. Nothing weird's happening over here. It's the same way the other two problems were. But the structure here compared to what it was. If we take a look at the other three problems we've done so far. Negative 3 squared, a single object squared. 6 squared, a single object squared. 5 squared, a single object squared. Each time I'm just squaring a single object. Now I've got 3 minus x, a binomial squared. Okay, so I'm going to take that over here real quick. 3 minus x squared looks like that. And if I'm doing a binomial times a binomial, I have to FOIL it. 3 times 3 is 9. 3 times negative x is negative 3x. Negative x times 3 is negative 3x. Negative x times negative x is positive x squared. So this binomial squared becomes x squared minus 6x plus 9. Okay. And again, if you have an x outside of the radical, that's what's going to happen each time. You're going to usually have x in a number. Those numbers come over here. You're going to get a binomial squared. So you have to square the binomial. Right? The other thing that happens here is we get a quadratic trinomial. We have an x squared and an x and a constant. So now we want to go to the factoring technique for solving a quadratic. So if it's a quadratic and I'm trying to solve for x, my first task is to get everything to one side equal to 0. X moves over as a negative x, negative 1 moves over as a positive 1. So what's left on the left-hand side is 0. On the right-hand side I have x squared minus 7x plus 10. Once I get to that point, it's now looking for factoring. It's going to be x minus 2x minus 5. That's equal to 0. Negative 2 times negative 5 makes the correct product of positive 10. Negative 2 plus negative 5 makes the correct sum of negative 7. Again, that's basic factoring. We've learned that since lesson 69. And then the zero product property tells me that either factor 1 equals 0 or factor 2 equals 0. Once we have factored form equals 0, as we just said, each factor equals 0 individually. So that gets me x equals, if I move the 2 over, it's going to be plus 2, 0 plus 2 is 2. Move the 5 over, becomes plus 5, 0 plus 5 is 5. So what happens is I get two solutions to this problem, positive 2 and positive 5. And I have to verify both solutions. Either they work or they don't. If they work, fine. If they don't work, we throw them out. So what's left to do is the check. And you have two numbers to check. You have to check them both individually. So let's start with x equals 2. I'm checking x equals 2. What I'm going to do is go back to my original problem here, change all the x's into 2's and see what happens. So I'm going to get the square root of 2 minus 1 minus 3 plus 2 equals 0. This x and this x both became 2's. Everything else is what it was. 2 minus 1 in the radical is 1. The square root of 1 is 1. Negative 3 plus 2 is minus 1. 1 minus 1 is 0. 0 equals 0 is true. X equals 2 is a fine answer and it works perfectly. The other answer we found was x equals 5. Alright, so for checking x equals 5 again, here's my problem. This x and this x both become 5's. So I get the square root of 5 minus 1 minus 3 plus 5 equals 0. This x and this x became these two 5's. Everything else is what it was. This gets me the square root of 4. Minus 3 plus 5 is supposed to equal 0. Square root of 4 is 2. Negative 3 plus 5 is plus 2. 2 plus 2 is 4, 4 equals 0 is false. So x equals 5 is no good. We throw that answer out. The only correct answer to this problem is x equals 2. That's usually what happens when you have a multiple answer. Usually one of them works, the other one doesn't. The only time I usually see multiple answers working is back to example 3. X squared equals number, then you get multiple answers that work. When it's like this, usually only one answer works. But don't not test another number just because I said that. Always check both, see if they work or not. If they work, fine. If not, throw them out.